Circular motion Part 2. There are two kinds of circular motion: horizontal circular motion and vertical circular motion. Horizontal circular motion is a uniform circular motion because only the direction of its motion is changing. Uniform circular motion is moving at a constant speed since it is at the same height, where acceleration due to gravity is not a factor. In other words, horizontal circular motion is a uniform circular motion wherein gravity does not really affect its acceleration. Acceleration is constant because every part of the string or object moving in circular motion is at the same height from the ground. This is an example illustration of a horizontal circular motion. The dot at the center is the centripetal force. The yellow line is the string attached with an object at the end. The red circle is the path of the string moving in circular motion. And the blue arrow is the direction of the motion. The green arrow represents the height of the string from the ground. Every part of the string is at the same height from the ground, therefore, gravity is not a big factor of its acceleration or speed. Another kind of circular motion is vertical circular motion. Vertical circular motion is a non-uniform circular motion in nature. Its speed decreases and increases as it goes up and down around the circle respectively. Its maximum speed is at the highest of the circle while its minimum speed is at the lowest point of the cycle. In other words, vertical circular motion speed or acceleration is not constant and gravity is a factor. This is an example illustration of vertical circular motion. The dot at the center is the centripetal force. The yellow line is the string attached with an object. The red circle is the path of circular motion. And the blue arrow is the direction of circular motion. The green arrow is the height of different part of the string from the ground. Obviously, there is part of the string when it is at the minimum height and maximum height. The height is not the same as it goes in circle. Therefore, the gravity is a factor since, if the string is at the highest height, the speed increases. And when the string is at the lowest height, the speed decreases. For example, the guys are moving in vertical circular motion. If you notice, when they are going up, the speed decreases. But when they are going down, the speed increases. It's because of gravity. As they go up, the gravity is pulling them down, which makes it decrease its speed. But when they are going down, the gravity is pulling them down, which makes the speed increase. Circular motion and law of acceleration. Since there is a centripetal acceleration in circular motion, Newton's second law of motion is applied. To calculate the centripetal force of an object moving in circular motion, use the formula, F is equal to m times v squared divided by r, wherein F is the centripetal force or tension, the unit is N, Newton. A is centripetal acceleration, the unit is meter per second squared. M is mass of an object, the unit is kilogram. V is the tangential speed, the unit is meter per second. And r is the path of the radius, unit is meter. Example problem. A 54-gram object is whirled horizontally using 50 cm string. It takes 12 seconds to complete 10 revolution. What is the tension of the string in order to keep the stone moving in circular motion? Identify the given 54-gram object as the mass of the string. Convert 54 gram to kilogram. If you remember your Science 7, you were taught how to convert units, but you can also simply research it. 0.54 gram is 0.054 kilogram. 50 centimeter string is your radius. Convert centimeter to meter. 50 centimeter string is 0.5 meter. 12 seconds is your time. 10 revolution is your N. The missing or what is being asked to solve is the tension of the string or centripetal force. Since tension or centripetal force is missing, use the formula for tension, which is F is equal to m times v squared divided by r. You cannot solve for the tension if you don't have frequency of revolution and tangential speed. Therefore you need also to solve for it. You will have to solve for three equations: frequency of revolution, tangential speed, and centripetal force. For the solution, solve first for the frequency of revolution. F is equal to 10, which is your N, divided by 12 seconds, which is your time. The answer is, F is equal to 0.83 Hz. Next is solve for V. V is equal to 0.83 Hz. Times 2. Times 3.14 which is your pi. Times 0.5 meter which is your radius. The answer is, V is equal to 2.0662 meter per second or 2.61 meter per second. Now that you have your frequency of revolution, and tangential speed, you can solve now for centripetal force or tension. F is equal to 0.054 kilogram which is your mass. Times 2.61 meter per second squared which is your tangential speed. Divided by 0.5 meter which is your radius. First solve 2.61 meter per second squared. If you square 2.61, it means multiplying it by itself. 2.61 times 2.61 is equal to 6.81. Distribute the square to meter and second. The answer would be 6.81 meter square per second square. First multiply 0.054 kilogram times 6.81 meter square, then divide it by 0.5 meter. The answer would be F is equal to 0.73548 kilogram meter per second, or 0.74 Newton.